Hi everyone, and welcome to this video series talking about how to do wall running in a first-person game. So there's lots of ways of doing wall running. There's lots of different design ideas around it too. So I'm going to show you a few concepts, a few models of this, and I'll also show you where you can customize it to your own liking. So let's jump in and get started on making our wall running for our first-person character. So in the first-person template, we haven't done anything in here. It's just a basic template. We want it to register a hit with the wall and movement of the character and let our character move along the wall. Now, there are two ways of doing movement along the wall. So let me just, for example, pretend this blue box is our character. When you're on the wall, you can either do a timed wall run. So it goes from starting here and goes dead straight like this, and then it drop you. Or we can also do it with a curve. So when you're on the wall like this, we change the gravity somewhat and it goes down gradually. So that's what we're going to try and do, is try and give you the option to choose which way you want to do this and show you where you make the changes yourself. There we go, back to how it was. There you go. Okay, so the first thing we're going to do is we need to be able to detect the wall. That's critical chance number one. Okay, so what we're going to do is we're going to use a hit event, and a hit event fires whenever you as a player character bump into anything. So when you do that, we're going to get the wall and more importantly get the normal of the wall. Then the normal is important because that's how we determine the direction that we want the player to move in. Okay, and that's how we get them to stick to the wall. So first thing is first, event hit. Let's just break it down into the individual steps. We're going to print string the other component that we are hitting, and that should return us the wall name as we bump into it. So if I jump into the wall, there is our component name we're bumping into. Perfect. So I now need to get the normal of that. So thankfully we have the hit normal, and if I can use this to limit the player character's movement. So on the character movement, there's a thing on here. If you scroll right down to the bottom, and it's called constrained to plane. Where is it? There it is. Planar movement, constrained to plane. And so what we're going to do is turn this on and then set the normal we're constraining to. So I'm going to drag out my character movement, and we're going to do set constrain to plane enabled. And we're going to take our character movement and do set constraint normal. And plug that in. And what we should see here is the character will bump into it and get locked to it. So as you can see here, I can't move off this wall now. Okay. If I jump, I can, because if I jump, I'm landing on the constraint of the floor. So next thing we need to do is determine if we're bumping into a wall or a floor. So that's going to be our end result, partly anyway. So now we need the condition. The condition is checking if it's a wall or a floor. So first thing we're going to do is check if we're on the wall. Now what I'm going to do is make a function to handle this. So I'm going to do check for wall. And what we're going to do is going to take the hit event that's coming from our event hit and feed that into the check for wall. So we're going to go to the inputs and search for hit event. Hit result, there you go. And we'll do hit. Now with the hit, we break it open, we get access to all that familiar content that we've seen many times again in other places. So to determine whether or not the thing we're hitting is a wall, I need to know the direction that we're going in. So I'm going to take the wall normal, which is the direction of the wall, and I want it to check to see if it's to the left or to the right of the character. So what I'm going to do is I'm going to do a dot product, and the dot product is going to be compared against our actor's right vector. Now, a good way to see what's going on underneath the hood here is to pause right here and just print string that float that's coming out of there. And if I go ahead and put that function now on my hit event and plug in my hit, just going to disconnect the end of this for a second. If I bump into the wall, you can see if I bump into it, it gets close to 1. Yeah. If I bump onto the other side of the character, it gets close to -1. If I bump into the front of it, it becomes 0. So I don't want to wall run when I'm head first into the thing, okay? So I want to take in that dot angle, and that angle is going to change slightly based upon my approach to the wall. So you can see as I'm running up against the wall, the value is changing, and it's going between like 0.9 and like 0.7, maybe 0.8. Those sort of things will determine how we're going to round this up. So check for wall. We need to say yes or no, we're on the wall. So the value for the dot here, it'd be negative and or positive. So we're going to do absolute. And what absolute does, it knocks off that negative value sign. So it becomes all positive. And then from that, I want to work out if it is greater than a value. So we go greater than, and we go 0.8. Let's get that thing there. And if it's greater than 0.8, we can assume that we're up against a wall. So let's go and do a print string. And this will return true or false if we're up against a wall. True. The false you're seeing is when I hit the floor. But if I bump into the wall, we're not up against the wall. We only want it to the sides of the character. Okay. Okay. So we've got that return value. So let's return these information. Return node. And we're going to plug in our Boolean into the return node to say we know whether or not we're up against a wall. And we're going to plug that in like so. And you may want to output as well the hit event information. Could be quite useful to pass it through. And we'll do wall hit. There we go. So we've got a check for wall going in here. And what we're doing here is nothing related to like setting a value or changing a value or doing anything like that. We're just getting information as it comes. So what we can do is actually make this a pure function. So I'm going to go to this side here with pure, which you get access to when you click on the purple node. And back on the event graph, that is now turned into this green function node. This is what we call a pure function. And I can use the return value to determine the condition. And the condition is, am I against the wall? Yep, then we constrain the plane. So if I go across the wall now, I'm now locked to the wall and nothing I can do can get me off of it. Okay. And if I were to hit the other wall with this arm, it would work against that arm. Okay. Okay. So we need the ability to start wall running and stop wall running. So what I'm going to do is I'm going to create a function called start wall run. And another one called stop wall run. And the code we've got currently on our hit, where we're constraining the plane and it's normal, I actually want to take this information and I want to cut it and put it into start wall run. Now this is going to need the plane normal, so we're going to drag that out and plug that in to our input node. And on stop wall run, I'm going to do this same thing, but we don't need the constraint anymore. We can get rid of that. And we're just going to turn off the enabled there. Back to our event graph, we've got true and false, so now we can do start wall run on true, with the plane normal coming in from our hit event. And if false here, we'll do stop wall run. Now, a good reason to have these as separate functions is because if you want to say, make the player get hit by something, we can just call the function to tell it to stop wall running straight away. We don't have to do any sort of weird injection of code. We can just go stop wall running and just drop. Okay. So speaking of stopping the wall rundown, not only do we have the hit event to check if we're on the wall, but another good way of doing this as well is if you're landed. So you can, there's an event called landed, and we can just do stop wall run on landed. And that's, it only works if you land on the floor. So if I go along the wall now, I'm constrained to the wall until I hit the floor where I can walk away. Okay. Okay, so not too bad. Next is we want to change the velocity of the character, so don't just keep falling at normal rate. So you want to give that appearance that the character is sort of sliding along the wall. So on our start wall run, we're going to manipulate the gravity scale of our character. So I'm going to go to my character movement, and we'll do set gravity scale. And the default for gravity scale on the character is important to make note of, because that may be different based upon what kind of game you're doing, what kind of movement you want. So it starts off at default of 1, but you may be changing that per your game. So just double check, make sure you've got the right value. So when we start wall run, we're going to turn it down to 0.2. And when we stop wall run, I should just copy that. I'm going to take it back to its default of 1. So once again, we're going back in and regularly testing that idea. There we go. And we got that curvature going on over here. Now, as you can see, the interesting about this is because it continues your momentum, you get that natural sort of like curvature of movement that you would expect to see in a wall run. So let's do a very simple test here. I want to make this wall a bit taller. And I'm just going to put in another block there. And we'll do a little test scenario. When I... oh, too far. And as you can see, we can like go up, okay? So what I'm going to do is I'm actually going to tell our character to not take any more vertical movement. So they'll just continue moving. And I want the character to not take inputs from the character controller as well. So it just sort of carries you going. The other thing we need to take care of is making sure that we don't start a wall run unless we're in the air. So let's go to our check for the event graph. And we'll do on the check for wall, we're going to, let's go to start wall run and do it in here. So the condition for this is going to be checking to see if the character movement is falling. And if we're falling also means true for going up as well as down. So it's not necessarily accurate in the way it says it's falling. Falling can also mean rising. So if I'm walking along here, I'm not going to get any weird behavior. Okay, so let's just go against this wall. And up. Oh, but if I push the jump key. There you go. So a very simple way of doing a wall run. So the other thing is that we want to maybe put a timer on our wall run so that we can't wall run forever. We want to eventually just drop our character. So let's go back to our start wall run. So when we go and start wall run, we want to trigger a timer. So at the end of here, we're going to do set timer by event. And we're going to take our event pin and do create event. And we're going to call the stop wall run here after a certain amount of time. And we can do this as like, let's do 1.5 seconds. Compile that. Save that. So now my game will drop me. Bit easier if I could see the thing. Let's just do that. So I'm gonna make it so I can see the timer. So I'm gonna return value here. We're gonna promote that to a variable, and we'll do wall run timer. And I'm just going for testing purposes, going to put this on tick. And get the remaining time. And printing that out. And I'm just going to make that duration of 0. And what that means is that it will just show on the screen for that single frame, which for tick means it's just constantly on the screen. So it says 0. Right, so if I jump on the screen here, let's try it again. I think it's resetting the timer by the looks of it when you hit 0. I know, it's fine. Yeah, not too bad. Okay. I think I just need to adjust the timer on that a little bit. So I'm going to go to start wall run and just put it down to maybe like 0.75. So half of what I just did. Yeah, so it is resetting it, see? Sometimes it is resetting based upon how the collision's working. So I don't want it to do that. I want it to reset and won't let me wall run until I detach myself from the wall and or land on the floor. So what we're going to do is we're going to have a checker on our start wall run to say can wall run, basically. So we're going to have a variable in here saying can wall run. And that's going to be a Boolean. Okay. And I'm going to drag that out and set that to false at the end of our start wall run. On stop wall run, we're going to put that on to true. Back on start wall run, we're going to add a condition at start here by doing a little and node. And we'll put that is falling and can wall run is on. And turn it on by default. Back in my event graph, I can also make it reset the can wall run on landed. So when I put that on there, we can turn that back on to true for landed. Okay, so now we should see it not resetting that timer until we hit the floor. That's it. Oh, why is it not going back on? Let's take a look at why it's not going back on. Can wall run becomes true. Can wall run is true. No, that should be okay. Let's double check I'm doing that right in here. No, what's going on there? So the issue I think might be, yeah, so in stop wall run, we don't want it to turn it off. We keep that compiled. So only way it turns back on is if we land on the floor. There we go. So there we have the start of our wall run. We've got the wall running, but now there's lots of little design things we need to think about. So first of all, we're going to make it so it resets the wall run after we leave one wall and go to another wall. So if we are going on the opposite side of our character, we can chain wall jumps together. Okay, so that's something we're going to work on in the next part. The next part as well, we're also going to work on that trajectory that our character follows when they hit the wall as well. So at the moment, it's a bit up, we go up to high and things like that. So we're going to fix that and make that a bit more consistent and easier to follow. And then we're going to go into a few more little details to help make this work better for your game by making it work for only particular surfaces. So you can watch that next part right now over on patreon.com/Ryan Laley. We can find that part plus many other videos early before anyone else from just $1 a month. A massive thank you to all the patrons and YouTube members for their continued support in the channel. If you like what you're watching here, make sure you subscribe, and I'll see you next time. Bye everyone.